Hello, mathematicians, and welcome to a new lesson. This is Mr. Garcia, and today we're going to be starting a new unit on circles. We're going to open up this new unit by talking about the parts of circles. So we're going to be looking at different lines, segments, arcs, and angles that form different parts of the circles. Each of these parts have unique properties, and we'll be discussing those properties in future lessons. So let's start with our objective for today. I can identify various lines, segments, arcs, and angles that are part of a circle. Let's take a look at the first part, which is the circle itself. No surprise there. So what a circle is a locus of points equidistant from a central point. Now, if that vocabulary is confusing you, let's break this down. Locus means group. So I have a group of points. Equidistant, we've seen the word equi before. We know that this part means equal, and distant means distance, right? So what we're saying is that a circle is a group of points that are all the same distance from a central point. You see that here, point A, I have this circle around it. So each of these points on the circle are the same distance away from point A. To name a circle, we call it by its central point. So for example, since this central point is A, we would call this circle A. And the perimeter of a circle is called its circumference. We don't have a true perimeter here because there's no sides to a circle. So instead of calling it the perimeter, we'll call it the circumference instead. And we talked about how to find the circumference back in the last unit. So go check those videos out if you need help finding the circumference of a circle. So now let's break down the circle into its other parts. We have radii and diameters. So a radius is any line segment that connects the center of a circle to any point on its circumference. So if we start from the center of the circle to any point on the circumference, it would look something like this. And so that is, and let me do this in green. And so that right there is a radius. It goes from the center of the circle to the circumference. So let's say this is point B. So we would call this radius. And since this is a line segment, AB with a bar over the AB. So we would call this radius segment AB. Now let's take a look at the next one. Diameter is any line segment connecting 2 points on a circle's circumference that passes through the central point as well. So now we pass from one point on the circumference to the other point, but it also passes through the middle. So something like this. And we'll call these points over here C and D. And so here's our diameter. We have 2 points that are on the circumference, and this line that connects those 2 points passes through the center point. So we can call this, since it's also a segment, we'll call it diameter, not A, diameter CD. A diameter is exactly twice the length of a circle's radius. So since the radius goes from the center to the circumference, and the diameter goes all the way across the circumference, then the diameter, D, is 2 times whatever the radius is. So that's what we mean when we say the diameter is exactly twice the length of the circle's radius, or that the radius is exactly half of the circle's diameter. These two say the exact same thing. It just depends on which one are you looking at first. Are you looking at the diameter? That's twice the radius. Or if you're looking at the radius, then that's the diameter divided by 2, split in half. All right, let's continue. Now we're going to talk about chords, tangents, and secants. So here's where we get into a little bit of unfamiliar territory. We haven't seen these parts before. We've seen radius and diameters. We haven't seen these. So a chord is a line segment that connects 2 points on a circle's circumference. Now notice that it doesn't say it has to go through a specific point like with the diameter where it has to go through the central point. A chord is any line that connects any 2 points on the circumference. So it could be something like that, or it could be something like that. It could even be a diameter like that too. That's also a chord. So chords just go through the circle, doesn't have to pass through any specific point, and it connects 2 points on their circumference. So let's call this B, C, D, and E. So if I want to call these chords, I can call it chord BD. I also have chord CE. Now, 2 chords are congruent if and only if their intercepted arcs are congruent as well. So what we mean by their arcs is that this arc is the same length as this arc. If that is true, then the chords themselves are also congruent. We'll review this property more in depth in a future lesson. So let's take a look at tangents. A tangent line is a line that intersects the circumference of a circle at only one point. So now we have a line that touches the circle at one and only one point. For example, this blue line right here. You see that it crosses at point E, but that's the only point on the circle that it touches. Doesn't touch anything else. So this line here is only touching point E. So we can call that tangent. And because this is a line, I'm going to call this E. And let's make another point. Let's say F. So tangent EF. And there's my tangent. Remember, we need 2 points to be able to name a line. Now, if a radius and a tangent intersect at the same point, they are perpendicular to each other. We're going to be talking about that property in a future lesson as well. But for now, let's look at the next part, secants. A secant line is a line that intersects the circumference of a circle at 2 points. A secant can also be a segment if it intersects the circumference twice and one endpoint is outside the circle. So let me show you what I'm talking about. Let's say that I have a line and it goes all the way through here. Now you see that it's kind of similar to a chord. It crosses at 2 points on the circumference, but this time instead of just stopping, now it goes and keeps going through the circle. So this is a line now. So a secant has to be a line crossing through 2 different points. Let's call that R and S. So I have secant line RS. But a secant can also be a segment if it intersects the circumference twice like RS does, and it also has one endpoint outside the circle. For example, let's say that I have a segment that goes through point D, goes through point S, and it finishes over here, and we'll call that one point Q. And this is a segment now. If I only say segment DS, then this will be a chord. Segment DS is a chord. But if I say segment QD, now this is a secant because you have that one point that's outside of the circle. So that's what makes a difference between a secant and a chord. So be careful with that. Let's continue. Now we're going to be talking about angles. So we have two types of angles that we're going to talk about right now that go inside of a circle. We have central angles, so let's start there. A central angle is an angle created by two segments that pass through a circle's central point. They can either be radii or diameters, and its vertex is the central point of the circle. So if I want to draw a central angle, the key to remember here is that the vertex of this angle is always in the center of the circle, which means that the legs of this angle are going to be radii. So I have two radiuses here that form this angle. I could also have a diameter instead of a radii, and I would still have a central angle there. So this central angle, let's call these points B and C here. This angle, which goes through the center, we can call that angle BAC. Now, what we need to remember about central angles is that a circle's total central angle measure is 360 degrees. Maybe you've heard that before, which means that if I make different central angles, let's say all of these central angles, and I would measure each one, their measures would all add up to 360 degrees. There's always 360 degrees inside of a circle. Remember that. The measure of a central angle is equal to the measure of its intersected arc. So for example, if I say that this angle, let's say it's 40 degrees, then the arc is also 40 degrees if I measure the angle of the arc. When we get to the section about arcs, I'll expand on this a little bit more. All right, so let's clear some of this stuff up. So I went and cleaned the circle back up so we can talk about the next type of angle, which is an inscribed angle. It is an angle created by two segments, at least one of which does not pass through a circle center. All endpoints are on a circle circumference, including the angle's vertex. So what that means is, if I had both endpoints on the center, that would be a central angle because you have both of these segments here. An inscribed angle means that I have, for example, a line like this, and I can have at least one line that goes through the center. It's not necessary, but I can. But the idea is that the vertex cannot be on the center of the circle. So let me define some of these points. Let's say I have D, E, and F over here. So angle D, E, F is an inscribed angle. What makes this inscribed is that the vertex is not on the center and the entire angle is contained inside the circle. You had something extending outwards like that. With the vertex outside, that's not inscribed anymore. The vertex has to be on the circumference of our circle. So even something like this is also an inscribed angle. Let's say this is J, K, and L. Angle JKL is also inscribed. Now, it also says the measure of an inscribed angle is exactly half of the measure of its intersected arc or of the central angle that shares its two endpoints. We're going to discuss that in our next lesson, actually, I believe. So hold on to that idea. We'll talk about it. Finally, arcs. So an arc is a portion of a circle circumference. A piece of this circumference is an arc. The measure of an arc is the measure of the central angle that intersects it, which we can call its intersected arc or its corresponding arc or corresponding angle. Now there's three different types of arcs that we'll be seeing. A minor arc is an arc with a length less than half of the circle's circumference and with an angle measure of less than 180 degrees. They're named using the endpoints of the arc. So let's say I'm going to highlight this part of the circle, just like that. And I'm also going to draw a point here and connect it to the center, and draw a point here, connect it to the center. So we've created a central angle here, but we also have the arc coming out here. So let's say if I call this BC, then angle BAC is the central angle that corresponds to arc BC. And the way that we write the name of an arc is we have the two endpoints of our arc, and we make a little arc on top of those two letters like that. So here we're calling it arc BC. As another example, let's say I am going to highlight this part over here, just that piece. And I want to put an endpoint D here and make a line to A. So now angle DAC corresponds to arc DC or arc CD. Either way, it's still the same arc. And we call it a minor arc. Only two letters on the endpoints are needed to name it. But now let's talk about the major arc. So a major arc is an arc with a length of more than half the circle circumference and with an angle measure of over 180 degrees. So that means if it's over 180 degrees, I'm going to mark all of this, and that will be my major arc. Now, the difference between a major and a minor arc is that I'm still using the two endpoints to name these, but I also need to use a point in between those two. So if here my endpoint is B and D, I have point E somewhere in between them. So if I start from B and I follow this arc, I go from B to E to D. So I can name this arc B, E, D. What about if I have more than one point on the major arc? Like let's say over here, I have R. Well, I could also call this B, R, D. So that could be arc BRD. So it doesn't matter if I use E or if I use R, as long as my endpoints are the same. I could even flip my endpoints around and be DRB or DEB. That works as well. All right, now the semicircle. Hopefully you're familiar with the semicircle a little bit. A semicircle is an arc with exactly half of the circumference of a circle and an angle measure that is exactly 180 degrees. And they are also named using the endpoints of the arc and one point that's in between them. So here, I drew a diameter. I have my diameter here. And you see that I'm starting at point B. And I'm going to call this point, let's say point, what letter have I used? Q. So if I want to name this semicircle, I want to name the arc. I know that I'm going to start with B and Q. Those are my end points. And now I'm going to choose a point that's in between them. So I have E and R. Again, I could use either one of those. And then draw my arc over them. And now I've named my semicircle. And again, that's going to be this arc right here. And forgive me for not following the line exactly, but you get the idea, right? And so that's how I name a semicircle. That's how I identify it. All right. Well, that's the end of the lesson, guys. Pretty short, But make sure you go back and review these parts because you are going to need them for the rest of the unit. I have posted a reference sheet for you guys to look at on Google Classroom, so please take a look at that. It's basically these notes but summarized into one picture, two pictures actually, so you can use that to help you on your assignments. All right, so have a nice day, guys. I'll see y'all later and take care.